You know, it's one of the smallest, most affordable parts in your entire engine. But let's be real, without it, you are going absolutely nowhere. I'm talking about the spark plug. Now, it might look pretty simple, but this little thing is a serious piece of high-tech engineering, and it has one of the toughest jobs in your car. So how in the world does this tiny component handle such a massive, violent job? Well, let's dive in and break it down.
So, here's what we're going to get into. First, we'll talk about the materials, the actual metals that make this thing work. Then, we'll look at the clever engineering behind the spark itself. After that, we'll tackle how it deals with insane amounts of heat. And finally, we'll get practical and figure out how to choose the right one for your ride.
Okay, so let's just start with the most basic, mind-blowing question. This tiny component lives inside your engine's combustion chamber. It has to survive millions, literally millions of violent explosions, temperatures that can soar over 850 degrees Celsius, and unbelievable pressure. And on top of all that, it's expected to fire a perfect high-voltage spark something like 20 to 30 million times before it gets replaced. How is that even possible? Well, it all starts with what it's made of. And that leads us perfectly into our first section, the material matters. See, a spark plug's amazing ability to just survive, let alone perform, is all about metallurgy, the science behind the metals used for its electrodes. This is really the foundation of everything. This chart basically tells the whole story of spark plug evolution. You start with your standard copper core plugs. They're fantastic conductors, but their melting point is, relatively speaking, pretty low. They were the standard for a long time. Then we level up to platinum, which is way more resistant to wear and tear because it has a much higher melting point. But the king of the hill today? That's iridium, with a melting point of over 2,400 degrees Celsius. I mean, that is just insane. It's built for extreme longevity and the brutal conditions inside today's high-performance and turbocharged engines. And this, right here, this is the fundamental engineering problem they had to solve. You absolutely need that copper core because it's an amazing conductor for heat and electricity. But copper's soft. It would just get eaten away by the spark in no time. So the brilliant solution was to cap that copper core with a tiny tip made of something incredibly hard. And right now, iridium is the champion. It's over 6 times harder than platinum. And because it's so tough, engineers can make the electrode tip ridiculously fine. And as we're about to see, that tiny detail is the real secret to a much better spark. Okay, so we've got these incredible materials, but that's only half the battle. Now we get to the really clever stuff in Section 2, engineering the spark. Because the plug's physical design literally has to fight the laws of physics to create that perfect ignition every single time. And the number one enemy that engineers are constantly fighting, it's a phenomenon called quenching. Okay, imagine trying to light a tiny matchstick in a huge cold metal room. The cold metal would just suck the heat right out of the flame. That's quenching. The relatively cool metal of the plug's electrodes can literally absorb the heat from the initial spark, killing it before it can grow into a proper flame and ignite the fuel. It is the ultimate spark killer. So how do you defeat this spark killer? Well, Bosch came up with a really slick solution called their pin-to-pin design. The big insight was realizing that larger electrodes are the enemy. They're just big heat sinks. So by putting an ultra-fine iridium pin on both the center electrode and the ground electrode, they radically shrink the amount of metal surface area that can steal heat from that initial spark. Less metal means less heat loss, which means more of the spark's energy goes exactly where you want it, into igniting the fuel. It's just brilliant. All right, but I know what you're thinking. What about those wild-looking plugs with 4 ground electrodes, like the Bosch Super 4? I mean, common sense says more has to be better, right? 4 electrodes must mean a bigger, better spark. Well, the reality is actually a little more interesting than that. See, the Super 4 isn't about creating 4 sparks at once. That's a total myth. It actually works on what's called a surface air gap principle. The spark is lazy. It will always take the path of least resistance. With 4 possible paths, it just automatically picks the cleanest one. If one of the electrodes starts to get a little dirty with carbon, no problem. The spark just hops over to a cleaner one on the next cycle. This gives it an incredible self-cleaning ability and makes it super reliable, especially for older engines or for cars that do a lot of stop-and-go city driving. It's a workhorse, not a racehorse. Its design is all about longevity and preventing fouling, not necessarily the absolute peak performance of a modern iridium plug. And all this talk about carbon fouling, cleaning, and temperature brings us perfectly to our third section, handling the heat. Because a spark plug doesn't just create a spark. It has to be a master of managing extreme temperatures. Surviving in that combustion chamber is all about thermal dynamics.
Now, the single most important and probably most misunderstood concept here is the heat range. And listen up, because this is crucial. The heat range has nothing to do with how hot the spark is. It's a rating of how well the spark plug can act like a radiator, pulling heat away from its own tip and transferring it into the engine's cylinder head to be cooled down. Getting this right is absolutely non-negotiable for the health and life of your engine. So how do they control this? Well, the main design difference is the length of this white ceramic part, called the insulator nose. Think of it as a hallway for heat to escape. A hot plug, on the left, has a longer insulator nose. That's a longer hallway, so the heat takes more time to get out, which keeps the tip hotter. A cold plug, on the right, has a really short nose. That's a super short hallway, a quick escape route for the heat, which lets the tip run much cooler. And this heat transfer is literally a matter of survival for the plug. A whopping 80% of all that incredible heat has to be conducted away through the plug's body, into the cylinder head, and into your cooling system. The plug is basically a thermal bridge, constantly funneling that destructive heat out of the combustion chamber. So, what happens when you get the heat range wrong? Well, if you install a plug that's too cold for your engine, its tip never gets hot enough to burn off the carbon and fuel deposits. It needs to hit about 450 degrees Celsius to self-clean. If it can't, all that gunk builds up and eventually it'll smother the spark, causing misfires and poor performance. But going too hot, oh man, that is way, way more dangerous. If the plug can't get rid of its heat fast enough, the tip can start to glow red hot. And that glowing tip can ignite the fuel before the spark is even supposed to fire. That's a nasty condition called pre-ignition, and it can lead to massive power loss and, as you can see here, literally melt the electrode and cause catastrophic engine damage. This is the stuff of nightmares for an engine. Which, of course, brings us to our final and most practical section, choosing your champion. Now that we understand all the science behind it, how do we actually apply this to pick the perfect plug for the job? You've probably heard this rule of thumb out in the wild: use Bosch for European cars and NGK for Asian cars. And you know what? There's a lot of truth to that, but not for some magical reason. It's all about OEM partnerships, original equipment manufacturer. Companies like BMW and Mercedes work directly with Bosch to design their ignition systems from the ground up, so a Bosch plug is literally made for it. The same goes for brands like Toyota and Honda with NGK. Sticking with the OEM brand is always the safest bet. So let's just put this all together in a dead simple checklist. Rule number 1, and this is non-negotiable: check your owner's manual. It will tell you the exact heat range and plug type your engine was engineered to use. Second, never ever downgrade. If your car came from the factory with Iridium plugs, you gotta stick with Iridium. Putting in platinum or copper will almost certainly hurt performance and longevity. And finally, manage your expectations. Sticking a fancy Iridium plug in an old engine designed for copper isn't going to magically add 20 horsepower. The real benefit you're getting is a massively longer service life. The incredible thing is, the technology inside this tiny component is always pushing forward. And as engines keep getting smaller, more powerful with turbochargers, and more complex with things like hybrid start-stop systems, the challenges of fighting pre-ignition and cold fouling are just going to get tougher. Believe it or not, the humble spark plug is going to have to get even smarter and more advanced to keep up.